After a fire, it is easy to see a dark deposit on a wall and describe it as soot. However, the material may not be soot, or even where soot is present, it may not originate from the fire being investigated. Soot, char and ash are often grouped together as fire residue, but they are not interchangeable. Each forms through a different process, behaves differently within the building, and provides different information about the event. Distinguishing between them is essential if particle deposits are to be interpreted as a meaningful evidence. Now, soot is produced during incomplete combustion, where there is insufficient oxygen for the fuel to burn fully. Instead of being converted entirely into gases and mineral residue, part of the material breaks down into vapor and extremely fine carbon-rich particles. These particles initially form as a microscopic nodules before joining into chains and larger agglomerates. Under magnification, combustion soot may show a characteristic branching or grape-like morphology. Because soot particles are extremely small and lightweight, they can remain suspended within the smoke plume and travel considerable distances. They may pass through corridors, ceiling voids, service penetrations and ventilation systems before settling in areas with no visible fire damage. However, soot is not specific to building fires. Candles, cooking, heating appliances, vehicle emissions and other combustion sources can all produce similar particles. Therefore, the presence of soot alone does not demonstrate that the area was affected by a particular fire. Its concentration, its morphology, in distribution and relationship with other particles must also be considered. Char is formed through pyrolysis. The material is heated and chemically decomposed, but combustion is incomplete and part of its original physical structure remains. The resulting particle may be dark, brown or black, but unlike soot, it can retain identifiable features from the material that produced them. Charred timber may preserve cellular plant structures. Charred fabric may retain a woven pattern, while cardboard on paper may show processed fibers. This retained structure can help identify the type of material involved in the fire. Char particles are generally larger and heavier than soot and are therefore more likely to settle closer to the source. But smaller fragments can still travel considerable distances. Soot often provides evidence of smoke movements, while char may provide evidence of the material that burned. Now let's talk about ash. Ash represents the largely inorganic residue remaining after more complete combustion. When most of the combustible carbon has been removed, and it is commonly grey and white or silvery. Also, color can vary considerably depending on the material involved and the combustion conditions. Ash from a building fire is rarely a single uniform material. Building contains timber, plaster, paint, plastic, wiring, insulation, metals and fabrics. Once exposed to fire, these may produce a complex mixture of mineral fragments, metal oxides, burnt pigments, glassy materials and melted or degraded polymers. Ash is therefore better understood as an assemblage of residues rather than one clearly definable substance. The distinction between soot, char and ash matters because visual appearance alone is unreliable. A black particle may be soot or char, but it may also be rubber, corrosion product, carbon black or degraded organic material. A pale particle may be fire ash, but it may equally be plaster, concrete dust or another common construction material. At Sysco Environmental, we assess soot, char and ash as separate but related form of evidence. Soot may indicate incomplete combustion and the movement of smoke. Char may represent evidence of the material that underwent pyrolysis. Ash may reflect the inorganic remains of materials exposed to more complete burning. None should be interpreted in isolation. A reliable conclusion is based on the overall particle assemblage, considered alongside the fire history, known source materials, building layout, ventilation pathways, distribution pathway, patterns, and background. Soot, char, and ash may originate from the same fire, but they do not form in the same way. They do not travel the same way or provide the same information. Correctly distinguishing between them is fundamental to understanding the source, distribution, and significance of the suspected fire residue.